Paper chromatography is a really useful chemical technique. It's something that allows you to separate out and find out what substances are present in different liquids or dissolved solids. In a minute I'm going to show you how to set one up and how to get a chromatogram. To do this you need some chromatography paper, a chromatography column, a splint to balance the chromatography paper on, a pencil and a sample of your dye. The first thing you do is draw a line on your chromatography paper in pencil so it won't move and put a cross on it. The second thing you need to do is take a sample of your dye. In this case I've gone for black food colouring. What you need to do is on your cross put a small dot of your liquid. You don't want it to be too big. And you want to do this quite a few times until you've got enough of your sample on there. Notice how I've put 2 on here. The next thing you need to do is put it into your chromatography column. You need to have water in the bottom. That is going to act as your solvent, and that will help to move the solid up through the paper. Place the chromatography paper into the water and you'll see it will start to rise up. The next thing you need to do is draw a line where the solvent stops. From this you'll be able to work out the RF values once it's complete, once it's dried. You can see from this that the black ink, which was the one on the right, has a number of different colours in there, including yellow, purple, pink and blue. So the very first step is to put spots onto the pencil line of each mixture that you want to test. So for example, in this case I'm going to have an unknown sample and then 2 samples that I do know, so I can find out which is the culprit. Step 2, you need to put your piece of filter paper into a beaker or chromatography column with a solvent like water or ethanol. This will help to dissolve the solid, dissolve the mixture that you've put onto the paper and move it up the filter paper. Just like that. The solvent line will start to move up the paper, and when it reaches the different substances it will start to move those up the paper as well. For example, in this case, if I have an unknown mixture M and 2 different samples A and B, I could run a chromatography to see which colours, which dyes are in the same as the mixture. So if I know that A gives me those 2 dots and B gives me these 2 dots, I know that M is the same mixture as A. Something you may be able to ask to work out in the exam is how to work out the retention factor. Now the retention factor is the ratio between the distance travelled by the dissolved substance and the distance travelled by the solvent. So how far the substance that's dissolved has moved compared to how far this solvent line has moved. The equation to work that out is distance travelled by substance divided by distance travelled by solvent. This number will always be below 1, so if you get something above 1, just put the numbers the other way around and that will give you your answer. Again. So the first thing I need to do, if I wanted to find out, for example, the red dot, find out the retention factor of the red dye, I'd get a ruler and measure first of all the solvent line. So that's how far it's travelled from the piece of pencil line all the way up to the blue line, which here you can see is 5.7. Then I'd have a look at the red dot and see how far that's moved up. Usually go about the top of the dot. So that comes out at about 3.7. So, because you need to have a number smaller than 1, in this case it will be 3.7 divided by 5.7. This would give me a retention factor for the red dye of 0.65. So just to summarise that, you take the distance of the solvent, you take the distance of the solid that's dissolved, and it's that B, so the solid dissolved, divided by A, the solvent line.